So if we have any questions while I'm going through this, just feel free to ask them in the chat or to turn your mic on and I'll answer them. Okay, so I have two questions that I want to work through today. And they really look like your questions from your week 9 assignment that you'll have to do. So if you follow along with these lectures here with your calculator and have kind of have an understanding of how to do these problems, I highly encourage you to jump right into the week 9 assignment because you know, after seeing me do these problems, you should be able to knock those problems right out of the park. Okay. So here's question 1. Okay, question 1 goes like this. According to the Department of Education, college students spend an average of 150 minutes on their phones per day. So that's the average right there, okay? So just to help see a little bit here, what I'm saying here is that the population mean for how much time college students spend on their phone is 150 minutes per day, okay? To be honest with you, I just made that up. I don't know what the real value is, but I'm sure we all spend more time on our phone than we realize. With a standard deviation of 75 minutes. So the next part here, what this is saying is that the population standard deviation, sigma, is equal to 75 minutes. Okay, so then suppose a random sample of 36 college students is taken. So that's n is equal to 36, okay? College students is taken, and the mean time of those 36 students spend on their phone is recorded. Right, so what you'll notice, and this was the same kind of a problem like you had last week too on the quiz, I'm gonna ask you for some type of probability with this, okay? So what is the probability that the sample mean is less than 140 minutes per day? Well, here's the first thing I'm going to do. I'm going to define a variable. So I'm going to let x bar be equal to the mean time spent on the phone of the 36 students. Now, this x bar is actually just a random variable because before I talk to the 32 college students, or 36 college students, excuse me, I have no idea what their mean will be. So I want to find now the probability that this x bar, this average mean, is less than 140 minutes per day. Okay, so we want to figure out what that is. So now there was this theorem that we learned last week, and it was called the central limit theorem. And I'm just curious, does anybody remember? You can type in the chat, or you can turn your microphone on. The distribution of x bar is going to be distributed how? Does anyone remember? Be distributed as yep, there it is right there in the chat. Yep, it's going to be a normal distribution. So the mean so the average here, mu sub x bar, is just going to be equal to whatever the population mean was. So it's going to be equal to 150. And then the other one we had was you need to find the standard deviation, which we called sigma x bar. Sorry about that, sigma. And does anybody remember what the formula for that was? You take the population standard deviation and you divide it by the square root of what? Does anybody remember? Yep, square root of n. Perfect. So this right here just ends up being equal to the population standard deviation, which was 36, divided by the square root, or excuse me, 75, divided by the square root of the sample size, which is 36, So let's just grab our trusty calculator here. 75 divided by the square root of 36. And you should get this, okay, which is 12.5. All right, so now we're just going to use our trusty calculator to answer this problem. Okay, so I want to find the probability that X bar is less than 140 minutes. So does anybody remember what option we're going to use in our calculator for this? I'm going to go second function distribution. And then is it number 1 or number 2 that we're going to use? Yeah, you got it. Thank you. We're going to go down to number 2, normal CDF. We're going to hit enter. And so here's the deal. I want to be less than 140. So by lower bound here, I'm going to have to put in negative 9999. You're going to have to put in something ridiculous. Your upper is going to be 140 because you want to be less than that. So that's where you're going to stop. And then my mean here is going to be this value here of 150, whatever the population mean was. And then my standard error here is going to be this value here, this 12.5. That's why I calculated it. So you're going to paste this in. So what this probability is, I'm just going to write it down. It was normal CDF, negative 999. We're going to go to 140. The mean was 150. The standard error was 12.5. And that's going to be equal to, let's check, 0.2119 when I round it to 4 decimal places. And that's our answer right there. All right, so this was a little bit of a review. Does everybody remember kind of doing this last week on the take-home quiz? Kind of ring a bell a little bit? Okay, a few people are like, yeah, good. All right, so let's just answer this last one real quick then. So the next question says, what is the probability that the sample mean is between 140 and 160? Okay. So now I'm asking you the probability that X bar is between 140 and 160. So the probability goes 140 is less than X bar, which is less than 160. So for this, you're just going to use that normal CDF again. So you're going to go to normal CDF. And so now you want to be between 140 and 160. So you're going to go 140 to 160. The mean is still 150. The standard error is still 12.5. So my normal CDF 140 to 160 with a mean of 150 and a standard error of 12.5. It looks like this should be 0.5763 when I round it. And that's your answer. So not too bad for this first problem. Still kind of like a good little bit of a refresher for everybody. So when you go to do your homework this week, your homework is going to be 6 problems. Take the quiz online, and the first 3 problems are just going to be this same exact type of problem. Okay. So you think you'll be able to knock those questions out of the park? Can I go over? Yep. Can I do that at the end? Let me just get the to answer your question. Yes, I will go over week 8, number 6, but let me just go through the next question first. Is that okay? Okay. All right, let's take a look at question number 2 here. Okay. All right, and then I'll go back to the week 8, number 6 for sure. So question number 2, this is the new stuff here. Okay, this is kind of what your lecture is going to be on this week. And just out of curiosity, has anybody looked at the lectures this week? Okay, and so this type of stuff, this question here is ultimately going to be the same type of problem. that I just did. Just the notation is a little different and the formula is just a little different, okay? So question 2 goes like this. As of 2007, so this is a little bit old, the United States Census Bureau reports that 27% of the population has obtained a bachelor's degree or higher. So what this is telling us right off the bat is the population proportion of people who have a bachelor's degree or higher is 0.027. Right, so then suppose a random sample of 200 adults is obtained. So that tells me my sample size. And what we're going to do is we're going to talk to the 200 people. And we're just going to say, do you have a college degree? Do you have a college degree? Do you have a college degree? So on and so on. And we're going to compute the sample proportion of people who have a college degree. Okay. And now in 200 people, it might not be exactly 27% who have a college degree because this is just a random sample of 200 people. So sometimes when we call 200 people, we're going to get a value above 27%. Sometimes we call 200 people, we'll get a value below 27%. So describe the sampling distribution of p hat here, okay? The sample proportion of adults who have a college degree. Okay, well, we know that p hat will be normally distributed. Okay, so it's just like x bar would be normally distributed. P hat is also going to be normally distributed with the mean. And what the mean is equal to. The mean we denote as mu sub p hat. And that's just equal to whatever the population proportion is. And that's just equal to 0.27. All right, that's always, always, always. Now the standard error, or the standard deviation, another name for it, we denote as sigma p hat. And this formula is a little bit more complicated. It's the square root of p times 1 minus p all over n, which is equal to the square root of p, which is at 0.27 times 1 minus 0.27 divided by our sample size, which is 200. Okay, so this is just a formula you need to follow. So this is equal to, I'm going to grab my trusty calculator here. Okay, so what I have to do is I have to plug this crazy thing into my calculator over here. So I'm going to go second function square root 0.27 times in parentheses 1 minus 0.27, close the parentheses, divide all that by 200. Now, if you have a TI-83 calculator instead of a TI-84, you have to be careful. It's going to start with a set of parentheses. You're going to have to end the set of parentheses. And you should get this number here. So 0.0314 when I round it to 4 decimal places. Right, so that's what you have to do there. Always you have to find, you have to tell me when I say describe, it's normally distributed, and then what is the mean and standard error? Always, always, okay? Then once you do this, the next two parts are exactly like the questions here. You're going to use the normal CDF, and it's pretty straightforward. So let me show you how to do this. All right, so what I'm about to show you is exactly what type of questions are going to be on your quiz this week. So in a random sample of 200 adults, what is the probability that less than 25% have a college degree? So it's the probability p hat is less than 0.25. Well, you're going to solve this exactly like we did with the mean, but just with the using these values here. So you're going to go second function, distribution. And what option did we use in the previous section here? Yeah, it's always going to be the normal CDF this week. Okay, always, always, always. So if you're not using this normal CDF, you're going to make a little bit of a mistake. So go down to the normal CDF. I want to be less than 0.25. So my lower number, I'm going to put something ridiculous, negative 9999 for my lower. It's going to go up to 0.25. And now it's going to say, hey, what was the mean? Well, this is your mean here, 0.27. What is your standard deviation here? That's this number right here, 0.0314. So what we did here was we went normal CDF, negative 999, all the way to 0.25, comma 0.27 is the mean, 0.0314, that's standard deviation that we just found. And it looks like our answer is 0.2621 when I rounded. And that's it right there. That's our answer. So the only thing you had to do here that was a little bit harder compared to the previous problem is you had to do this step right here. This is the harder part right here. So the mean is always going to be whatever the given proportion is. And then when you go to find the standard deviation, you're just going to have to use this formula right here. Okay, that's it. That's the hard part for these problems. All right, but now that you've seen me do this, does it not seem too bad? Are any questions about it? I know it can be a little bit confusing and stuff, but I promise you, if you watch the videos I've posted here, and I'm also going to share this video too via email in a little bit, I promise you it's not too bad. All right, let's just do the last question here. So in a random sample of 200 adults, what's the probability that more than 30% have a college degree? So now it's the probability that p hat is greater than 0.30. So here it's just going to be the normal CDF always. So since I want to be a greater than, my lower value is going to be 0.30, and the top value is going to be something ridiculous like 99999. The mean doesn't change, it's 0.27, and the standard error doesn't change either. So going back, here it's going to be second function distribution, always normal CDF, always. Here I want it to start at 0.30 because I want to be greater than 30%. I'm going to go up to something ridiculous like that. The mean and standard error doesn't change, so that's good. So just like I put on the problem down here, this is 0.1697 when I round it. And that right there is our answer that we're looking for. So your homework this week is going to ask you to do exactly this. Okay, exactly what I did in problem 1, and then exactly this stuff in problem 2. You're going to have 3 probability questions on your homework from question 1 and 3 from question 2. Okay, and you have unlimited attempts, so you can keep practicing till you keep trying to get it right. All right. Any questions before I go back and answer that one that somebody asked about? Okay, so there was a question that looked like someone wanted me to go back and do week 8, number 6. Is that correct? So week 8. This question right here, number 6, does that sound about right? Okay. So this question right here is exactly like the first question I did today. So it says the following: suppose the mean time for an oil change at someplace that claims it's a 10-minute oil change joint. So the average is 11.4 minutes, and the standard deviation is 3.2 minutes. Okay, if a random sample of 25 oil changes is selected, what is the probability the mean time will be greater than 12 minutes? So the trick here is what you had to do was you first had to start by finding out what the standard error is. So you're going to take standard deviation of 3.2 and the sample size of 25. So you're going to take 3.2 divided by the square root of 25, and you get 0.64. So we want to find the probability that it's greater than 12 minutes. So you would go second function distribution, normal CDF. We want to find greater than 12 minutes. So you'd start at 12. You would go to something ridiculous like this. The average is 11.4. And I think, I forgot it, shoot, I think it was 0.64 was that standard error I just found. And it should be 0.1742. So it should actually be this number here that's the closest to it. The reason this is off a little bit is because I use the standard normal table here, but your calculator gives you the better correct answer. So you would have to just pick this one that's closest to it. Does that help? Okay. More than welcome. So that's the problems I had worked for you guys. I'm going to share this recording and I'm going to email you the link to it. I'll post it to YouTube and then email the link. But before I go, does anybody have any final questions for me or anything, in general they want to ask or say? I'll actually stop the recording here in case somebody wants to ask something without being recorded.